So picking up right where we left off, right now if I play the animation, the ball is technically bouncing, although it isn't very realistic. It kind of looks like a spaceship, right? It's very floaty right now. So let's open up our graph editor and find out how we can make this look a bit better. So I'm selecting my ball, gonna click on the graph editor shortcut in the shelf, and here's my curve, my animation curves. Now all we're concerned with right now is translate Y, because that's the main attribute that is causing the ball to go up and down, to move up and down. And we could see that the interpolation is set to auto tangent. So auto tangent is this button right here. And by default, the software tries its best to make every single curve an auto tangent. It's the computer's own interpretation of what it thinks the movement should be in between two keyframes. So here are my two keyframes. In between, the software has filled it in with what it feels is the best version of that, if that makes sense. It's basically what happens in between two keyframes. Okay, and we can change this. Sometimes the software does a good job of interpolating between keyframes. Other times it does not do a very good job. And this is an example of one of those times where it does not do a very good job.
You had one job. Just the one?
So we can see that as the ball approaches the ground, this is frame 1, the ball is off the ground. Frame 12, the ball hits the ground. And frame 24, the ball is back off the ground. So as it approaches the ground, the line here isn't linear. It's not approaching the ground at a constant speed. It actually is slowing down as it approaches the ground, and that's what creates this kind of floaty motion. So I'm selecting this one keyframe here, just this one, because that's the only thing we want to change right now. And I'm going to click on the linear tangent button. Okay, I'm just going to undo that. If you don't see this, you can also go to tangents and linear, and that does the same exact thing. Okay, just by doing that, let's look at our animation. So I'm going to close this and play the animation, and now we can see that the ball is not slowing down as it approaches the ground. So it's already looking a bit more realistic. But let's continue to refine this animation. Back in the graph editor, so frame 1 and 24 are good, but the interpolation could be changed a bit. So right now I feel that it's dropping a bit too fast or too soon. So what we want is for the ball to stay up in the air a little bit longer and then drop after a few frames. And how can we do this? I'm selecting this first keyframe, and I'm going to go to curves and weighted tangents. So look at the handle that just changed, right? I'm going to undo that. The handle is kind of a small pointy triangle. When I go to curves, weighted tangents, the handle becomes sort of an elongated square shape. And now I can take this, I can click and drag it outwards. And this is actually changing the interpolation. I'm going to do the same thing on the opposite end. So here you just kind of need to eyeball it. It doesn't have to be perfectly symmetrical, but we are aiming for something even on both sides. So this more or less seems to be okay. And I can always come back in and tweak it a bit more later on. Now you can see down here, it kind of messed up our nice linear movement. And now it's kind of doing this weird slowing in, and then there's a snap here at the bottom. So I'm going to select this keyframe here on frame 12. And we're going to split this tangent in half. So right now if I try to adjust it and make it straight again, it's actually messing up the right side of the graph. So what we have to do is split this tangent in half so that we are able to move one side of the tangent without affecting the other side. And the split tangent button is right here, or break tangents. Alternatively, you can go to the tangents menu and click on break tangents. So now you can see that the lines are dotted, the handles are dotted, which means now I can click and drag without affecting the other side. And I'm just going to line this up with the green line so that it is nice and linear. So it starts off weighted, but then as it approaches the ground, it becomes linear. Now let's see how our ball looks with these changes. All right, that's a lot better. So the ball has sort of a spring now when it bounces, and it stays up in the air for a bit longer. So we get this nice variation in movement. Now the last main step is to add some stretch and squash. So the ball is going to be squashed in frame 12, and it's actually going to be stretching right before it hits the ground. So maybe at around frame 11, 10 or 11. But let's do the squash first. You can see that if you add up the three values of scale x, y, and z, it equals 3. So keeping this in mind, the object should always maintain its volume when you're scaling it, or when you're adding squash and stretch. Which means if I start squashing this, these three values no longer add up to 3. If this is 0.5, now I have to compensate, which means I'll have to make this 1.25 and scale z 1.25. And for all you math nerds out there, if you're good at math, that's great. If you're not good at math like me, you can bring out your calculators. It's just a simple formula. We know that the scale always needs to be 3. So we have to do 3 minus the amount that you have squashed or stretched it. So in this case, my scale y value was 0.5, and this equals 2.5. Now, for scale x and scale z, they both have to be the same value because it squashes and stretches evenly. All right, so this has to be divided by 2 because I need two values that add up to 2.5. And it's 1.25, which gives me my answer. So I have 1.25 plus 1.25 plus 0.5 equals 3. And then this is an accurate representation of how it would squash and stretch. Okay, so that's frame 12. Now frame 11, it's not going to be squashed. It's actually going to be the opposite. So let's stretch this out. I'm going to bring all of these back to my default scale of 1. And now, again, just eyeballing this, you can feel free to stretch this to your heart's content. But remember that it still has to maintain its volume. I'm stretching it to 1.25. Or let's say 1.5. Using our formula, 3 minus 1.5 is 1.5. And that divided by 2 is 0.75. So these three values still add up to 3. And that's how we know that we have maintained our volume. Now, frame 11 is good. Frame 12 is good. We have stretch here and squash here. When it leaves the ground, it's going to resume its stretched position. I'm going to select everything I have on frame 11, right-click, go to copy, and we're going to paste this on frame 13. So paste and paste. So frame 11, 13, and 12. Let's view our animation. So it's not bad. Right now it's stretching at frame 11 and squashing at frame 12, but that just gives us one frame to register the ball squashing. And one frame is a very, very short amount of time. It's not enough time for our eyes to interpret what's going on. So instead, we need to add a little bit of a buffer, a little bit of room so that our eyes can register and understand what's going on in between these three frames. Right now we have a very big jump and it's a very drastic change. So in frame 11, I'm actually going to bring the ball a little bit closer to the ground, just a bit, so that it's not as big of a change as before. So going back and forth between frame 11 and 12, we can see that this is a little bit better. Frame 13, I'm also going to bring this down a bit. It doesn't have to be exactly the same as frame 11, but it should be similar. So on frame 1, make sure the ball shouldn't have any squash or stretch. So frame 1, this should be 1, 1, 1. Frame 24, 1, 1, and 1. Okay, let's see how it looks. It's a lot better. So now our eyes can actually interpret what's going on in between those two frames as it's bouncing because it's not that big of a change. If you want, you can still tweak this. So let's say I want maybe one frame in between frame 11 and 12. So I want an additional frame where I can see the ball transforming into its squashed shape, because right now it's going from one extreme to the other extreme. We can actually move frame 11 over to frame 10 and see how it looks. So I'm holding the shift button and I'm left clicking once. Now let go of the shift button and you can use these arrows here in the middle, these yellow arrows, and drag it over to the side. Okay, and now you can see that the pinstripe or the keyframe has changed from frame 11 to frame 10. So now in frame 11, that's what the computer has interpolated for us. Now that doesn't look very realistic. The ball is kind of frozen in that one spot. So let's go to our graph editor and see what the problem is. In translate Y, I can see that the interpolation is messed up, right? So the computer is kind of getting confused. The software is getting confused. It doesn't know what's going on. All we need to do is select these frames where it's messed up. So I'm clicking and dragging a selection, and then I'm going up here to the auto tangents button. And this is going to force the tangents to smoothen out. And now it's a lot better. If we go now to frame 11, we can see a more accurate representation of the movement in between frames 10 and 12. Let's view the animation. All right. Now some animation shortcuts. Anytime I want to play my animation or view it, I can click on the play button here. Alternatively, you can hold the Option key and press V for volleyball. So Option V will actually play the animation, and pressing the Escape key will stop the animation. Or you can press Option V to toggle your animation. So Option V will start and stop your animation from the frame where it was previously paused on. If I want to delete a key, so let's say, since I have my auto key on, I'm going to really mess up frame 15 and say, okay, that's what I did. And then I'm playing the animation, and oh, what's happening to the ball? It's going crazy. So frame 15 is my messed up frame. And if you find a frame that you don't want to keep, simply go to the frame, right click, and press delete. Now we can tweak this for days and days. In order to just understand the basics, I think we can stop here for now. So we added in stretch and squash, we adjusted our tangents, and we used a lot of the principles of animation that we learned, right? There's slow in and slow out. As the ball is approaching the ground, that's slowing in and then slowing out at the end. There's some exaggeration, there's stretch and squash, and there's timing, right, as we adjusted our keyframes here. So there's many principles of animation at play here, which is why the bouncing ball is such a great exercise for beginners and even experts. It's always good to come back to this to revisit the fundamentals. Okay, one last tip I'm going to explain is the play blast option. So a play blast is simply a quick video preview of what our animation will look like. Think of it like a screen capture. So the software will actually record our animation on screen and spit it out in a very rough QuickTime format. So all you need to do to create that is right click on the timeline and you'll see Play Blast at the bottom. But before you actually click Play Blast, let's click on the box beside Play Blast. So anytime you see these small little boxes on the right side of the menu, those are the options for the current command. So I'm clicking on the box beside Play Blast, and here let's just change it to H.264 and make sure this is AV Foundation if it isn't already. Sometimes it might be image, and that's going to spit out a whole bunch of images on your computer. We don't want that. We just want one clean video file. Display size from window, we can keep it at that, which means however large my viewport is will be the size of the video, which is good. And then scale is 1, so we're not going to scale down the video. It's going to be at its true scale of the viewport, and we can leave frame padding. You also have the option of saving this video to a file, but for now we can skip that. So I'm going to click on Play Blast. It's just going to scrub through the timeline, record the animation, and now QuickTime is going to open up. I prefer using QuickTime 7. It's an older version, but one thing it has that the newer versions of QuickTime do not have is the ability to view frame numbers. So now I can see my individual frames, although it's offset by 1 frame. So you can see how it starts on frame 0, even though our animation starts on frame 1, but that's okay. So let's play the animation, and also I'm going to press Command L. Command L will loop the animation. Okay, so that is the end of the bouncing ball exercise. In the next video, we're going to start animating a pendulum swing. I'll see you there.